for students again, because you get back to triangles. Okay, we start looking at what's called law of sines, law of cosines, and things like that. Some of you have had that in your background. So we actually start getting back to triangle stuff again. So I'm going to just do a few examples of some right triangle trig. And we did this way back at the beginning of the semester to some extent. Okay, first of all, what I want to go through is show you the convention that you name right triangles. Okay, I want you to draw like two triangles, right triangles like this. So what we always do is, you're generally going to see me write it one of two ways. We always use capital letters, and C is the right angle. A and B are the other two angles that are acute. Okay, then we use lowercase to represent the sides. So that would be A, opposite B would be little b, and opposite that's little c. That's what you're more familiar with the Pythagorean Theorem, a squared plus b squared equals c squared. Okay, we also do this sum. In Greek, alpha, beta, gamma are the first three letters of the Greek alphabet. You use a lot of Greek letters in mathematics. So I'm going to use like alpha and beta like that. And then it's still the same. This side's A, that side's B, that side's C. So that's real important when you're doing these problems, as you understand the naming convention of a triangle. That's what that is, okay? So we're going to solve a couple of right triangle problems here. And we're going to go through, this is the SOHCAHTOA stuff again. And then we're going to do this review part. And then when we get back from spring break, then we'll be looking at some of the parts of this section that are a little bit new to us, because there's a few ideas. Okay, so let's look at solving this triangle. So what I've given you is like this, and I'm going to label that as C. So I've given you B is equal to 6, and I've given you A is 30 degrees. You got to find the rest of the triangle, okay? So the idea, if I say solve a right triangle, you got to find the remaining parts. Okay, well, let's start with something real simple. Let's start by finding B. You can do B in your head. You know that by now. What is that? 30, right? Okay, it's a 30-60 right triangle. So what you're really doing when you're finding B is you're just doing 90 minus 30. These two angles, A and B, always add up to 90. Okay, so that's going to be a 60-degree angle like that. Okay, all right. Now what we're going to do is, we've got that done now. So I'm going to focus in. I always try to tell students when you do these problems, use what I gave you. Don't use anything you found, because you may have made a mistake. Okay? So what we're going to do is, let's just pick something that we want to find. Let's start with A. We want to find A. And then you got to go back to SOHCAHTOA. Or how did I teach? Oscar has a hairy old ass. I taught it that way, right? There's that one too, if you like. So SOHCAHTOA is the most common, so let's think of it that way. Okay, so if you look at this triangle, it's going to go like that. You focus on this angle. So what do you have? You have what? Side opposite and side adjacent, right? So which trig function are you going to use for opposite and adjacent? Tangent. Okay, that's how you know to use the tangent. You don't want to use anything other than sine, cosine, or tangent. So that means what we're going to do is we're going to write down an equation. We say sine of 30 degrees, not sine, tangent. Okay, so we're going to say tangent of 30 degrees is equal to opposite, which is A, over adjacent, which is 6. Okay, you can solve that equation. You're going to have to use your calculator on this too. On this section, we're going away from the unit circle now. We're just going back to calculator stuff now. So I'm going to multiply both sides by 6 to get that to go away. So I'll end up having A is equal to 6 times the tangent of 30. And I'm going to make sure I'm in degree mode when I do this. That's important. And then I just do 6 times tangent of 30 degrees, and I'll round this off to like whatever the problem says. So I think it says 2 decimal places. So A is going to be about 3.46. Okay, so we got that. All right, so does that make sense to everybody? Does that look familiar? We've done this kind of stuff before. Now you can find C by the Pythagorean Theorem, or you can do Trig. I'm going to do Trig. I just usually do it this way. I prefer doing Trig than Pythagorean Theorem. So now what we want to do is I'm going to look at these three things. Okay, I'm going to look at the two things I gave you that I've got highlighted in yellow in this. Okay, talk out what you have. And again, look at the angle. So what is this? That's the side what? Adjacent. What's that? Hypotenuse. Which one's adjacent over hypotenuse? Cosine. Okay, so that's how you know to use the cosine, right? So we're going to write down on that cosine of 30 degrees is equal to adjacent 6 over hypotenuse. Now that's a proportion. You can cross multiply and solve that like that. So I'm going to do this. I'm going to do C times the cosine of 30 degrees is equal to 6. And then I can divide both sides by the cosine of 30 degrees. Okay, and then I'll just use my calculator and then I'll round that off to 2 decimal places like that. Okay, all right, so when I do this in degree mode, we're just going to go 6 divided by cosine of 30 and then just round that off. So we're going to get on that 6.93 like that. So then the problem is solved, 6.93. Okay. All right. So that's how that goes. That would be the solution to that triangle. Okay. So that's the SOHCAHTOA stuff. All right. Anybody got a question about that? You guys remember that? Okay. Usually this is the part of trig that students do really well on, is the triangle stuff. Okay, let me do this one here, and then I want to do one problem and that number 4, and that'll finish us up. That's as far as I wanted to go. Okay, so this one we're going to draw a triangle on this. This is a right triangle. And again, you want to use the naming convention. That's important. So C is the right angle. Capital A and capital B are the other two angles. And then this is going to be B there, C there, and lowercase a there. So I'm going to write in what I gave you. I gave you A is 7, and I gave you B is 4. I always just give 2 parts of the triangle. So when I solve the triangle, I'm going to always use those things there. That's just the way I teach that. Okay, so first of all, well, we know this by now, obviously. We can find C by doing the Pythagorean Theorem. So we're going to crunch that out real quick, and we're going to use a decimal this time. So we have C squared is 7 squared plus 4 squared. So that is 49 plus 16. Okay, so that is going to be 65. We do the square root of both sides. We're getting a positive answer because we're dealing with a triangle, so distance is positive. So this time I'm just going to estimate, okay, and round off. So the square root of 65 is going to be about 8.06. So I'll record that, and that'll give me the first piece of the triangle, okay? All right, now let's figure out an angle. So we're going to pick an angle. It doesn't matter which one you pick. So I'm going to pick A. I'm going to start with A. Again, you talk it out. Okay, look at the angle A, and what do you have? Opposite and adjacent, so what do you use? Tangent. There you go. Okay, that's the ideal way to do that. Look at the angle when you talk that out. So we're going to end up with the tangent of A is equal to 7 over 4. So we got to do that. All right, now we've talked about this before. By now, maybe some of this will make better sense to you. Okay, what do you do on your calculator to find the value of that angle? If I give you the value of the tangent, do the inverse, right? Okay, remember the inverse is giving you the angle. So you go to your calculator and you just do the inverse tangent of 7/4. Okay, so we're going to do inverse tangent of 7/4. You want to be in degree mode when you're dealing with triangles now. Okay, so want to do that. So I'm going to go second tangent of 7 over 4. And then that's going to leave me with an answer of about 60 points. Let's just use 1 decimal. So let's just say 60.3 degrees. Okay, all right, so we got that, 60.3 degrees. Now all you got to do to find B is, if you know that's 60.3, what do you do to find B? Subtract from 90, exactly. So B is just going to be equal to 90 degrees minus 60.3 degrees. So I think that's what, 29.7 degrees. That's it. Okay, problem done. Okay? So you want to kind of know how to do triangles. Now, the reason that you want to know how to solve a triangle is because ultimately what you learn how to do is use this for applications in the field and measurement and stuff like that. So let's do this one problem here, and then I will finish this up. Now, sometimes the hardest part of these problems is figuring out where everything goes. Okay, so let me make sure we got that down. So what we're doing is we're measuring a distance across a lake. All right, so there's my lake. Okay, we're going to measure a distance across. We got to have a right triangle going on here somewhere. So we've got something there, and we've got something there, and we're going to let that be our variable right there. That's our x. So we're going to find the distance across a lake. Okay, so it says he sets up his transit on one side of the lake, 140 feet from the piling. That is directly, oh my God, directly across from a pier on the other side of the lake. Okay, hold on, let me think a minute here. Okay, let's see. It's directly across from a pier on the other side of the lake. Okay, so let's see, let's try this. Pier, there. Transit, here. Okay, then it says the piling is, hold on, the piling is directly across from a pier. No, I'm wrong. Let's see if this is right. The piling is directly across from the pier. That's what it says. Okay? Then it says the transit was the transit here or was the transit here? Okay, so he's got the piling is directly across from the pier. So we got that okay.
So the transit's below the X.
Yeah, that's it. That's it. Sorry. It always takes me a minute on these things sometimes. That's the hard part of the problem to me. Yeah, okay. So we got that. So that's the transit is directly from the, like that. Okay, so you got your right angle like that then. Okay, and then you're trying to find that right there. So it said, from his transit, the angle between the piling and the pier is 55 degrees, okay? So which angle is that one then? The one at the bottom or the one there? It's that one. That's the one he's measuring, because when you have a transit, that's what you're measuring. Now, to take you out of this stuff, generally what I'm going to do, my math lab generally tries to have a diagram there, at least to help you a little bit with that. Because the way I look at it, if you're out in the field surveying, you're going to know what you're doing, right? Okay, that's my philosophy. Okay, all we got to do is find this and we're done. Okay, so let's see. What we have on this one is we've got an angle, and they gave us one other thing. They said the transit on the lake is 140 feet from the piling. That's what I wasn't reading. That's why I was having trouble with that. So that's 140, like that. That's the setup. So what am I going to use? Sine, cosine, or tangent? What do you think? What do you think? Tangent, exactly. Okay, so we're going to do the tangent of 55 degrees is equal to opposite, which is x, over the adjacent 140. Okay, then we just solve this equation. So you can multiply both sides by 140. And then you're going to use your calculator to figure out that answer, and we'll just round. It says round to the nearest foot, so we do this. So we have 140 times the tangent of 55, and then that should give the distance across the lake. So that looks like we'll just round that to 200 feet would be the answer that we're going to get on that problem then. Okay? All right, so I think as long as you got a diagram, you'll be okay with that, I think. All right. So I think what you're going to get when we get back from spring break, get that second test done, then the easier part